Okay, from section 5 all the way through the end, I'm just going to kind of skip around and make sure that I do at least one example of every single type of problem. So some of these will just have double bonds and triple bonds. They might have two sets of double bonds, and then we'll start getting into shapes, and then we'll get to the front side of the foldable that has all of our functional groups. But I'll make sure to do at least one type of each problem so you can go back to that one for reference. And then if you still need help, just come see me. All right, so moving on to section 5, draw the structural formulas for each of the following. So 2-heptine, we have to start with our chain when we draw out the structures. So hept tells me 7, so I'm going to draw 7 carbon in a row. The suffix YNE tells me there's a triple bond, and I'm going to put that triple bond on the second carbon, because I know that because of this 2 out front. So on the second carbon, we need 3 dashes. So now we have to go through and put in our hydrogens. First carbon only has 1 bond. It needs 4 more. So I'm going to put 3 hydrogens on there. Our second carbon, it has 1 bond on the left and 3 on the right, so that's 4. The third carbon, same thing. It has 3 bonds on the left and 1 bond on the right, so that makes 4. The next 3 carbons only have 2 bonds each, so they each need 2 more. So we need a hydrogen on top and a hydrogen on the bottom. Our last carbon only has 1 bond, so it needs 3 hydrogen. All right, and so that would give us everything we need for 2-heptine. So we're through with this one. I'm going to shrink it down so I can move it. All right, so letter B, cyclopropene. Cyclo tells us that it's a shape, so we're on the back of the foldable still. Prop tells me that this shape has 3 points or even 3 sides. E and E tells me it's a double bond. So cyclopropene, a shape with 3 sides, that's going to be a triangle. And then one of those sides has a double bond. It doesn't matter which side. Well, this really needs to be closer to the bottom of the triangle. Hold on. There we go. That's a little better. So you could have put your double bond on the left. You could have put it on the right. It doesn't matter as long as you have a double bond in there. This one doesn't tell us specifically where to put it. All right, letter C. We have 3-phenyl 2,2-dimethylhexane. So we go to the very end of the name, hexane. We start with the chain. So hex tells me 6. So I'm going to put 6 carbon in a row. Ane, A-N-E, tells me that they're all single bonds, so I don't have to add any multiple bonds to it. And then before that I have 2,2-dimethyl. Dimethyl tells me I have 2 methyl branches. 2,2 tells me that both methyl branches are located on the second carbon. So on the second carbon, I'm going to put CH3 on the top, and I'm going to put CH3 on the bottom. And then it says 3-phenyl. Phenyl is the same thing as benzene, so it's still a hexagon with a circle. But now it's considered a branch instead of a chain. So since my smartboard isn't very cooperative, I'm going to cheat. I'm going to put a hexagon and a circle. Remember, that circle tells me that I have double bonds on every other side of my hexagon. All right, and so now that's my phenyl, and it needs to be attached to the third carbon. So I'm going to put it there. It could be on top or bottom, it doesn't matter, however it fits on your paper. And then you got to go through and fill in your hydrogen, and I'll do a condensed one this time. So my first carbon has 1 bond. It needs 3 more, so I'm going to put 3 hydrogen. My second carbon already has 4 bonds. It has 2 methyls and a carbon on the left, a carbon on the right, so it's done. The third carbon has 3 bonds, 1 on the left, 1 on the right, and a phenyl, so it only needs 1 hydrogen. The next 2 carbons, they only have 2 bonds apiece, so they need 2 more. And then my last carbon only has 1 bond, so it needs 3 more hydrogen. So there's 3 phenyl, 2,2-dimethylhexane. I'm going to shrink this one down. And now 1,3-pentadiene. Right, so let's go to this chain. We know penta is 5, so we'll do that. Nothing else, you can draw that part of the chain. Di, D-I means 2. E-N-E means double bonds. So I have 2 double bonds. And if we go back to the front of the name, 1,3. So that means I have a double bond after carbon 1. And I need a double bond after carbon 3. So it's pentadiene. So now you have to go through and fill it in with your hydrogen. Let's see, we can't do that with this one, so we're going to have to put it off there. Alright, and I think that should get everything for 1,3-pentadiene. Let's see, letter E, 1-ethyl-2-methylbenzene. So I'm not going to draw this one, but I'll talk you through it. Benzene, that's our hexagon with the circle in it. On the very first point of your hexagon, so the very first point can be whichever one you think is first, you're going to draw a branch. It'll have ethyl, so that's CH2CH3. And then you're going to count 1 point over to the second carbon on your benzene ring, and that'll be a methyl branch. So you'll draw in a CH3. Right. Letter F, you should be able to do that one. There's nothing out of the ordinary for F. All right, let's look at 6. Let's pull this back up. All right, so now we're getting a little bit different. Listed below are the condensed structural formulas, or the names for the 8 isomers of C5H11Cl. Write either formula and the name for each. You don't have to do both. I just want one or the other. So for the first one, we're going to treat that chlorine like it's a branch. And if you look at the front of your foldable where it says alkyl halides, you open it up, it lists fluorine, chlorine, bromine, iodine. And for the name, it just says O. So that means we're going to drop the INE and add an O. So now it becomes fluoro, chloro, bromo, and iodo. So for letter A, we're going to name our chlorine first because it's a branch. We have to tell where it's located. We have to use the smallest number possible, so that's 1 chloro. And then we have a chain of 4 carbons. There's no other branches. So the prefix for 4 is bute. And the suffix is -ane. So 1-chlorobutane. Your work be the same way. You have to add in your methyl group. All right, letter C, they want you to draw it out. So always start with your chain. That's pentane. Pent tells me 5 carbons. ANE tells me they have single bonds. 3-chloro. So on the third carbon, attach a chlorine. Right, and then you'll just fill it in with hydrogen. Right, so that is 3-chloropentane. Alright, I think you can do the rest of those. There's nothing too much out of the ordinary on those. So let's go on to section 7. Let's see, let's look at letter B. That one's a little bit different. We have our chain and we have one branch, but what's different about B is we have 2 double bonds. Your double bonds and triple bonds have to be in the chain. You can't have double bonds and triple bonds in a branch. So our longest chain on this one just goes from left to right all the way across. And then the CH3 at the top, that methyl, is going to be our only branch. Double bonds also take precedence. So what that means is when I'm numbering, I want my double bonds and triple bonds to have the lowest numbers from my branches. All right, so on this one, it looks like it doesn't matter if we number from left to right, we're going to get the same answer. So we have to tell where our branch is located first. And if we count, it's on the third carbon, and it's a methyl branch. Now I have to tell, before I can write the name of the chain, I have to tell where my double bonds are located. So the first one's after carbon 1, and the second one is after carbon 4. So remember, we use dashes between numbers and letters. We use commas in between the 2 numbers. We have to use correct punctuation. All right, so now we can name the chain. There are 5 carbons, so that tells me pent, or penta. I have 2 double bonds, so 2 would be Di, and double bonds, my suffix is Ene. I'll rewrite that last word so it's a little clearer. Pentadiene. So penta tells me 5, di tells me 2, ene tells me double bonds. I have a chain of 5 carbons. There are 2 double bonds. So letter B is 3-methyl-1,4-pentadiene. Letter C, this hydrogen down here, it's not a branch. It could be written up here in between the 2 C's. I realized later on that I had left it out, and so that was just the easiest way for me to add it and still make that correct. So I could really have just put this H in between those 2 carbons right there, kind of like this one is. So just ignore this H, you don't name it. On letter D, I want you to draw out some kind of structure that contains 5 carbon, only 9 hydrogen, and chlorine. And then I want you to name it. So come up with some kind of structure. Because you only have 9 hydrogen, you're going to have to put a double bond in there somewhere. So make sure you count and you put the correct number of hydrogens in. All right. Let's see. E through K don't look any different than B, so you should be able to handle those. Let's look at L. In L, we have 2 benzene rings that are attached together. We have 2 branches. Remember, bromine's one of those alkyl halides, so that comes bromo. When we have 2 of them that are the same, we call it dibromo, and we have to tell where they're located. So with shapes, we can use the lowest numbers possible. So I'm going to say it's on carbons 1 and 4. So 1, 4 dash dibromo. 2 benzene rings bonded together is called naphthalene. Naphthalene is essentially mothballs. if you don't know what mothballs are, go ask your grandmother. She can tell you. All right, I think that's pretty much everything for 7. Eight, I've covered everything for 8 already. There's nothing different there. You're just drawing them out instead of naming them. Let's skip on over to 9. And 9 is where we start adding in functional groups. So we're going to start with 9C. 3-ethyl, 2-methyl, 1-pentanol. So this OLE ending is new to us. If you look in your foldable and you flip over all the little flaps, look for something in the name column that ends in OL. Should be the very first one. Those are alcohols. The structure for it is OH. So when I see pentanol, pent tells me 5. AN tells me single bonds. OL ending tells me it has an OH group attached to it somewhere. I'll go back to this number where it says 1. That's where I'm going to put my OH group. So I'm going to draw 5 carbon. They have single bonds. On the very first carbon, I'm going to put OH. All right, so now let's go back one more. It says 2-methyl. So on the second carbon, I'm going to put a CH3. And on the third carbon, I'm going to put ethyl. Right. That covers everything in the name. Now we fill in with hydrogen. Right, so that is 3-ethyl, 2-methyl, 1-pentanol. So that's all there really is to it on functional groups. Let's do another one. All right, letter D. 3,3-diethyl hexanoic acid. Sounds terrible. Let's go to the chain. Hexanoic acid. Hex tells me 6. AN tells me single bonds. Oic acid, if you look in your foldable, carboxylic acids. Those are carbons with a double bonded O and a single bond OH. So we have an alcohol and a double bonded oxygen. Carboxylic acids don't have a number associated with them like the alcohols. Remember the alcohol on the one before, it said 1-pentanol, and that 1 tells us where to put the alcohol group. Well, carboxylic acids always occur on the very first carbon, so they don't need a number. So hex, I'm going to draw my 6 carbon. Oic acid. So on my very first carbon, I'm going to put a double bonded oxygen and a single bonded OH. And notice the bond goes from carbon to oxygen. The bond doesn't go from carbon to hydrogen. Hydrogen can only bond once. So that show that bond that it's going to oxygen. All right, and then if we back up a little bit more, it says 3,3-diethyl. Di tells me 2. Ethyl tells me it's a branch that has 2 carbons. They're both located on carbon 3. So I'm going to draw an ethyl group on the top and an ethyl group on the bottom. And then you have to fill it in with hydrogens. So that is 3,3-diethyl hexanoic acid. All right, letter E. Hexanone 2,5,5-trimethyl 3-hexanone. If you look in your foldable, ONE tells me a ketone. Right. If you look, ketones and aldehydes have the same formula. They're both double bonded oxygens. The difference, aldehydes are attached to the very first carbon in the chain. ketones are only attached somewhere in the middle of the chain or somewhere within the chain. So that's one of your questions on your functional group worksheet. The difference between an aldehyde and a ketone. They have the same attachment. They're both double bonded oxygens, but ketones are within the chain. Aldehydes are on the very first carbon. So hex tells me 6. On tells me double bonded oxygen. I'm going to put it on the third carbon. Switch colors here. On the third carbon, I'm going to put a double bonded oxygen. So there's my 3-hexanone. 2,5,5-trimethyl. Tri tells me 3. Methyl is CH3. I'm going to put 3 methyls on my chain. Where am I going to put them? I'm going to put 1 on the second carbon, and I'm going to put 2 on the 5th carbon. 1 on top, 1 on bottom. And then you fill in the rest of it with hydrogen. Be careful with your double bonds. Make sure you count that you only have 4. From here on out, I'm going to let you fill in the hydrogens. We're going to move this one out here. All right. You should be able to do F, octadiene, 8 carbons. 2, line E is a triple bond. So you're going to have 2 triple bonds. You're going to put them after carbon 1 and after carbon 7. You've done benzene. H, ethoxybenzene. A better name for ethoxybenzene is ethyl phenyl ether. So, look at the ether on your foldable. It just shows an oxygen. It has 2 dashes coming off. So what that means is we have an oxygen and we can attach something to this side and we can attach something to this side. So I'm going to attach an ethyl on one side of an oxygen and I'm going to attach a phenyl to the other side of my oxygen. Remember, phenyl is the same thing as a benzene ring. So I'm going to cheat again and I'm going to put my hexagon with a circle. And then I'm going to draw my oxygen here. CH2 has to be closest to the oxygen. Oops. I just keep screwing that one up. There we go. CH3, CH2, O, and then a phenyl. So this is ethoxybenzene or ethyl phenyl ether. Alright, so let's move that over. Alright, let's look at K. 2-ethyl 4-methyl butanal. That is pronounced butanal. So let's go to the chain. But is 4. AN is single bonds. AL, that's an aldehyde. We've already talked about it a little bit. It's a double bonded oxygen that occurs on the very first carbon, which is good because there's no numbers in front of butanal. So I'm going to draw 1, 2, 3, 4 carbon with single bonds on the very first carbon. I'm putting a double bonded oxygen. All right, 3-methyl on the third carbon. Put a methyl group. On the second carbon, it says 2-ethyl, CH2, CH3. So now fill it in with hydrogen. So that is your 2-ethyl, 3-methyl butanal. Right. I'm going to stop here, and I'll pick up in the next video on number 10.